Hi everyone, Mr. Kakbar here. Now we're going to go over this next problem. It says on Hugh's 18th birthday, his parents give him the option on how he might receive his monthly allowance over the next 2 years. You can get $60 each month for 2 years. You can get $10 the first month, $15 the second month, $20 the third month, increasing $5 each month for 2 years. Option C, $15 in the first month and increasing 10% each month for 2 years. Or investing $1,500 at a bank at the beginning of the first year with an interest rate of 6% per year, compounded monthly. These are his options. Well, anyway, they walk us through the problem, so don't worry about all of those quite yet. Hugh does not spend any of his allowance during the 2-year period. If Hugh chooses option A, calculate the total value of his allowance at the end of the 2-year period. So after 2 years, he would have what? 2 years, and there are 12 months per year. And he's getting $60 per month. So if we multiply all these together, units all cancel out, and we're left with $1,440. That's part A. Part B says, well, what if he chooses option B? How much money will he receive in the 17th month? Well, first we have to ask ourselves, well, what are we talking about here? Well, hopefully we saw increasing $5 each month is something we talked about in this chapter called sequences, specifically arithmetic sequences. And that's in our data booklet, or our formula booklet here. We have arithmetic sequences here and geometric sequences here. So we're going to be talking about the arithmetic sequences. And this is the sum of all the months. This would be for any one given month. So the first question asks how much money he'll receive on this 17th month. So you'd say, okay, in his 17th month, he will receive what? He will receive the amount he got in his first month, which was $10, plus n minus 1, n being 17, and d being the difference. Hopefully we saw the difference was $5 each time. So in his 17th month, he will get 17 minus 1, which is 16, times 5, which is 80, plus 10, which is 90. He'll get $90 on month 17. What is the total value of his allowance at the end of the 2-year period? Well, total would be, again, summing things up. It's different than what we had before. So the sum after the 2 years, or 24 months, would be equal to the number of months, 24, divided by 2, times 2 times the first month, which was $10, plus n minus 1, 24 months minus 1, times the difference, which was 5. All of that put into our calculator. So I'll go ahead and start over here. 23 times 5 plus 2 times 10, which is 20, and all of that times 24 divided by 2. You would have $1,620 at the end of the 2 years. Part C says, well, what about option C? How much would he receive in the 13th month? Now, this is a little more tricky. Here we have $15 the first month, increasing by 10% each month. So 10% as a decimal is 0.1. So if we're increasing 10% each month, we can actually multiply that. Multiply that not by 0.1, not multiply the previous month by 0.1, but by 1.1. Because we want the amount he had before plus an extra 10%. And this would be the common ratio used for geometric sequences. So here we got geometric sequences. It tells us for any one given month, we have a formula, the sum over several months, we have another formula. So the question asks us in the 13th month, how much money would he receive? So we go in the 13th month for geometric sequences. He would receive the amount he got the first month, which was not 10. That was the previous problem. For option C, he gets $15 the first month, times r, which is 1.1, all of that to the n minus 1 power, 13 minus 1. 15 times 1.1 to the 12th power equals 1.1 to the 12th power is that, times 15 gives us 47.08 dollars. So in the 13th month, you would get $47.08, rounding to the nearest cent. What's the total value of his allowance at the end of the 2-year period? Again, we're using the sum formula for geometric sequences. The sum after 24 months would be equal to, and both these are the same, so it doesn't matter which one we use. I'm going to use this one on the left. The first month times r to the n power minus 1. Notice that the minus 1 is not in the exponent here, it's down below. All of that divided by r, r is 1.1 minus 1. So we plug that into our calculator, and what do we get? I'll start with the top of the fraction first. 1.1 to the 24th power gives me that, minus 1 gives me that, times 15 gives me that. So I got 132.746, all of that divided by 1.1 minus 1, which is 0.1. So I take this previous value, and I divide by 0.1, which is the same as multiplying by 10, and we end up with $1,327.46. Doesn't look like a very good option, Hugh. Option D. If Hugh chooses option D, calculate the total value of his allowance at the end of the 2-year period. What was option D? Option D is this compound interest formula. So let's go to our compound interest formula. It says the future value would be equal to the present value, and they were going to give him $1,500 to begin with, times 1 plus the annual interest rate was given as 6, and we write that as a percentage. It's positive because he's earning money, so positive 6 divided by 100 times K. K is the number of compounding periods per year. If we're compounding monthly, that's 12 times per year. So K would be 12, and K gets put in 2 different places. K is here, and K is also in the exponent. And the final term, N, is the number of years, which is 2. We just plug all that into our calculator. I'll start here. 6 divided by 100 times 12. So that's this value right here. I'm going to add that to 1. That's this value here. I'm going to take that term and raise it to the 12 times 2, or 24th power. So that is this term here. I'll multiply that by 1,500, and that gives me my answer. Again, rounding to the nearest cent, we get that value right there. State which of the options, A, B, C, or D, you should choose to give him the greatest total value of his allowance at the end of the 2-year period. What number is the biggest? No, 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 yes. You should choose D. Another bank guarantees Hugh an amount of $1,750 after 2 years of investment if he invests $1,500 at the bank. The interest is compounded annually. Calculate the interest rate offered by the bank. All right, so we have to plug everything into the equation. So the future value would be $1,750. The current value, or the old value, we would put in as $1,500 times 1 plus the unknown R divided by 100. Compounded annually means K is 1, so I don't have to write it down. Compounded annually means K is 1, so I don't have to write it down. It's going to be after 2 years. So we have to solve this equation for R. Now, I don't think I'm going to give you this problem on the exam because this is a little bit outside the scope. This is more of a math problem. Can you solve this equation? So what we have to do is we have to isolate R, divide both sides by 1,500. This means 1.1666666 equals 1 plus R over 100. All of that squared. We take the square root of both sides. So 1.08012345 equals 1 plus R over 100. I subtract 1 from both sides, and I multiply by 100, and that gives me the rate. So R is equal to, sorry, it's off the page. R is equal to 8.01%. So let me just show you what I did. Again, I won't ask this problem on the test, but again, we have to isolate R, so we divide both by 15. And we get 1.16 is equal to everything that's left over on this side. We take the square root of both sides. We get 1.08 equals 1 plus this. We subtract 1 from both sides and times each side by 100 to get R is equal to 8.01%.